Okay, so section 10.2 is about, again, we're dealing with the making inference. We're looking at the inference on mu1 minus mu2. Okay, and this section is about the normal distribution. So we assume that this difference follows a normal distribution with given parameters. So we're dealing with the normal distribution. So one thing that we have to note, okay, is that the test statistic, and we're going to call this in this section z x1 x2 divided by the square root of this whole thing. Okay, so keep this in mind. Okay, so in this case, the standard deviations sigma 1 and sigma 2 are given. Okay, so if you're given that, given these two, then I can plug in these two numbers and compute the test statistics. So it makes our makes the problem a lot easier because I deal with the normal distribution, the standard normal distribution. So therefore, this makes a lot easy to come up with the decision. Okay, well, let's look at this example, two examples. So we're looking at these mean. Okay, so we're looking at the mean number of RPMs in two engines, and the question is, do the data indicate engine 2 has higher RPM than engine 1? Okay, so this is 1 and 2. So H naught, so HA would say is mu 1 less than mu 2, right? Or think about it different the other ways. Is mu 2 greater than mu 1? That's exactly what I want, right? Okay, so this means is that mu 1 is equal to mu 2. Okay, so you just always use equal sign in the null hypothesis. Okay, so now let's compute the test statistic. Okay, so Z so what I have is 1500 minus 1600. Okay, and then standard deviation is 50 square over, and how many from each here? Mm, 30, yes, both 30. Okay, plus 60. Okay, and let me compute this. Let me see what the value is. So this is about negative 7.01. Okay, and what I'm looking at is the standard normal, and this is 0, and negative 7.01 is going to be somewhere far left. Okay, so when you look at this area to the left, the reason why this is to the left is because I have less than. Okay, so this is a left tail. Okay, so I'm looking at the left tail. Okay, but when you look this up, well, this is going to be essentially 0 because the highest value that you will have is, I think this is like negative 3.499 or something. Okay, so when you look at the when you look at a more negative number, then that's going to be even closer to 0. Okay, so the p-value is approximately 0. Okay, so therefore we reject the null. Okay,